Okay, so I think we'll start. Also, the first slides are really introductions, so if people miss those, it's not that important. So, hi everyone. My name is Teixeira-Pinto, and I'm here with Katrina Blazek. We are both academics, academic biostatisticians at the School of Public Health, Faculty of Medicine. I presume that there's quite a few people outside of the School of Public Health. This one initially was a session organized to the school, but then we extended to the faculty. So welcome everyone. If you have the files for this session available in the link that Katrina is sharing in the chat. So it's basically 3 files. I believe it's just the slides, the R code that we're going to use during this session. You don't really need to download it. You can do it at the same time as I'll be doing it. And the third one is also the data file that we're going to be used. But again, there's going to be a direct link from R to the Dropbox, so you don't really need the file in your local computer. Okay. In any case, if you want to keep the slides and the R code, feel free to download it. So the other thing is, if you at any point have questions, you can either write them in the questions and answer, or in the chat as well. If it's easier, you can raise your hand and Katrina will unmute you and you'll be live with everyone. Okay, so feel free to to ask questions. So the idea of these 2 sessions is really came from talking with different colleagues and different students about R and the increasing interest on R. And I'm not sure if R is really the best tool for everyone. So this session is really to introduce you the basics of the program, to give you a little bit about the philosophy and the rudiments of R, so you can have a feel about the program. And if that's the case, you'll have the first stones to start building your knowledge around the program. Okay, so this is by no means you're going to learn R in these 2 sessions. This is really just to provide you an overview of the package. Okay, so in this session we're going to look at programming and the basics of programming, and some introductions to what are packages and libraries. And the second session that is going to happen next week, Katrina will lead that session, and she'll be presenting quite useful package to plot graphs. And this is something where you can see the potential of R in plotting graphs. Okay, so I'm going to cover RStudio and basically introduction to R, talk to you about what are objects and functions, because that's really the core philosophy of the program. Then I'll show you a few commands about managing data, and then I'll talk a little bit about packages and libraries which complement the programs. Okay, so a little bit of history. Some of you might know this, but the R started in '91 as a project led by Ross Yak and Robert Gentleman here in our cousin neighbors in New Zealand, in the Department of Statistics of University of Auckland. And they said they really wanted to implement statistical language in a freely available package that they could use with their students. So in '95, the project, it was growing and became a freeware under general public license. 1 year later, there was a formal group that was created, the R core group, which is nowadays is the one that is managing the development of R. In 2000, John Chambers, who's the designer of S. So S is a statistical language, programming language, and R is an implementation of that language. So R basically implements the language S. And John Chambers was the designer of that language, joined the R core. And since then, pretty much the software took off, and it's been growing at an incredible rate and becoming one of the most popular programs in statistics and data science. So currently we are in version 4.0.0, just came out a few weeks ago. If you just downloaded R and R Studio, so I'll talk about what's R Studio. R is really the program. You probably downloaded the version 4.0.0. And then there's already more than 15,000 packages available in CRAN. So packages are specific programs that are developed by third parties. So, people like, for example, myself, that create packages and then make them available in this CRAN. CRAN is a network of servers around the world that keep always updating the versions of R and the new packages that being available. Okay, there's servers spread around the world. We have a couple of them here in Australia, and you'll see this once we start installing packages. Okay, so if you're not new.
Sorry, someone's asked if it's possible to increase the size at all. They're saying that the slides are a little small.
It's maximized in my computer, so it's not sure how to. This is the maximum I can do. Sorry. I think I have a wide screen, and that's why you might be seeing a little bit smaller. But I'll need to share the screen with R. That's why I have it in a corner. Hopefully you can download the file, and if you cannot really read the slides here, you might be able to follow with the slides in the file. Okay. So I was saying you might not be new to statistics and might be using other software. I have here a comparison of, this is my opinion about the differences in terms of availability, user-friendly, how the new methods are updated and so on, and the comparison between the four main package of statistics, especially in the health sciences, so R, Stata, SPSS, and SAS. And the big advantage of R, I would say, is the fact that it's open source, so basically it's free. It's not really user friendly, so it's a programming language. Both SPSS is clearly the friendliest program among these packages because it's menu driven. Stata also has some menus, so I would say that Stata is also quite user friendly. SAS and R are really based on programming. The other advantage that the R has in comparison to the other programs is that when a new method is proposed in statistical community or a machine learning algorithm or something new, nowadays it's quite common that the authors immediately provide the code to implement that method, and usually that code comes in R. So anything new that comes in terms of methods, it's really almost immediately adopted in R, where for other softwares you have to wait for new versions to arrive. Okay, in terms of support, technical support, let's say, all the commercial programs have the technical teams, but there's also a lot of help in the web. In R, it's basically the community that provides the support, and it's very easy, in my experience, to find someone in the globe that had a problem like yours, and ask the question and someone answered. So it's quite easy to get help in R. But to be fair with the other programs, I think it's all of them are quite well supported in the community. Okay, so should you learn R? I think you might be in a better position to make a decision at the end of these sessions. Clearly, the advantage is that it's a free software. It produces or you have high control over the graphics, so you basically can do whatever you want in terms of plotting your data. As I said, it implements the new methods that appear in the literature. So most of the advanced methods are available. It's a programming language, so it's very it's harder, but it's very versatile in terms if you need to run simulations, or if you're developing a new method you want to implement it. It's really the way to go. It forces you to have a structure in your analysis that leads to reproducible research. So this is a buzzword nowadays, but basically because you have to program your analysis, you have the diary of your analysis that you can run at any time. Okay, the cost of all this is that it's really it's a more difficult program to learn because it's based on a programming language. Okay, so I'm just going to briefly mention some of the extensions of R that I think they are interesting. The R Markdown. So R Markdown is a way of writing documents, PDF documents, or Word documents, or for people that do LaTeX, also allows LaTeX, or even PowerPoint things. So it allows you to write these documents with R code embedded in the documents. Okay, so you can imagine that you're doing a report and you want to, at a certain point, produce a graph of your data, and you can put the code for that graph, and when you generate the document, it will create the graph in the middle of the document for you. Okay, and anytime that you created the document, that analysis is going to be redone. So you can write papers directly with R Markdown. I had a student that wrote an entire thesis in R, and it should press the button and it would produce the PDF with the entire thesis. It was quite impressive. But that's quite useful, and it's something that if you start using R, you probably will end up using for teaching in particular. It's really useful. R Shiny, it's a package, but I would say it's an add-on to R, which allows you to develop apps for the web, so web apps. And I'm just going to show you. This is something that I developed some time ago that implements. Let me bring it up here. So this is just an example of one of these Shiny apps. And it implements a risk calculator for cardiovascular risk. Okay, so this is a web page, as you can see, and now you have these sliders for age, that's installed blood pressure, and every time I change here, dynamically the plots are updated. Okay, so behind this web page, there's an R program that is really making all these calculations and updating the web page. And this is something that is relatively easy to do with this R Shiny. Okay, so you can create an app and deploy it in an easy way. There's hundreds, if not thousands, of Shiny apps now with all sorts of things, including. And at this time, actually, I've seen quite interesting things with COVID data. Okay, so some nice things with extensions of R. So where does RStudio, that I've asked you if you're interested in following this with hands-on to install, where does RStudio fits here? Well, the RStudio it's sort of what sits on top of the engine that is R. Okay, and it's a more friendly environment to deal with R. Okay. And then the libraries of packages, you can see that you can think of them as add-ons to your car, special seats or special wheels or this type of things. So there's other alternatives to RStudio. RStudio is the interface that is most popular. There's one that doesn't really follow the philosophy of the RStudio and the other interfaces, which is called Jamovi. And the reason I'm mentioning it here is because we are adopting it as an alternative to SPSS in our Introduction to Biostatistics course at School of Public Health. So this year, the Intro Biostat students are using Jamovi, which it's slightly different from RStudio in the sense that it's not something that sits in top of R, but it actually it's embedded with R. But it tries to simulate the point and click or the menu-driven approach of SPSS, and I would say with lots of success. And in certain aspects, I think that Jamovi is even easier to use than SPSS. Okay, and just a curiosity is the authors of Jamovi are three programmers. Two of them from Newcastle here, Australia, so not far away from Sydney, and we had the visit of them a few months ago at the School of Public Health. So it's really, and again, it's free and it's quite intuitive to use. Okay. Okay, so RStudio, you have the screenshot here. So if you open your RStudio for the first time, I'm going to bring it to the screen. So you have something like this. So this is what it's called, the console, and then you'll have on the right side some details about things that we'll talk a bit later. Okay, so you can write directly on your console, but what I'm going to do is to start an R script. Okay, and it's going to split the screen into parts, and this is the console where you write in something and you'll get the answer immediately. The R script is where you write your program, and when you decide, you execute the program and the result will come in the console. Okay, I'll show you this in a second, but if you open your RStudio, just leave it like this and I'll come back to it. Okay, so R is an object-oriented programming language. So what does this mean? That for R, most of the things are objects. Okay, and so what are objects? Well, objects can be something as simple as some data values. Okay, this would be the atomic objects. You cannot divide the data values, but a number is an object or a character or a string, or you can also have a data value that is just a logical value like true or false. Okay, and I'm just representing this with little boxes, so you can see that in other objects they have to be of the same type of data values. So as I was saying, objects can be data values. They can be vectors or matrices, so data frames and lists, and I'll define this a bit later, but these are basically data structures. But they also can be something more generic, like the result of a model, or a plot can also be an object. A table that you produce can also be an object. Okay, so pretty much everything in R are objects. Okay, so I'm going just to talk about this vector, matrix, data frame, and list because these are fundamental objects that you're going to deal with. So a vector, it's a set of data values of the same type. Typically in a data set, if you think about data sets, R can be used for other things. We're going to use it basically mainly for analysis. So if you think about the data set, an example of a vector would be one variable. Okay, for example, age, and the values of the age are all of the same type. So they're all numbers. Okay, it could also be some string variable like sex, for example, but you cannot mix different types of data. So a matrix, on the other hand, is a collection of vectors, but vectors with the same data types. Okay, so if you're talking about strings, they all have to be strings. If you're talking about numbers, they all have to be numbers. If you're talking about logical values, they all have to be logical values. And an example that you probably heard about, for example, would be a correlation matrix. That's what a matrix really is. And then we have a data frame, which is basically a data set. And this brings together different types of vectors, or potentially different types of vectors. Okay, so you can have numbers, you can have strings, you can have logical values, you can have another numbers, vectors, and so on. Okay, so this will be typically the data set. And finally, a more generic object, which is a list that can put together different types of sub-objects. So, a list can be formed by a vector, by a graph, by a matrix, by a data frame, by a table. So it brings together different type of objects, and it's quite it's quite a versatile type of object. Okay. Okay, so let's do a bit of R. It's been already 20 minutes and we haven't done anything. So let's create the first object, and objects in R can have names, and actually we're going to give names to these objects, okay? So I'm going to create this, my first object, named my first object, that is just going to be the number 4, okay? And you can either, again, write it in the script window or directly in the console. The advantage in the script is that it's going to stay there saved. If I write it here in the console, it's executed once, and it sort of disappears, the command. What I'm going to do is just to open, because if you want to follow the code without needing to write it, I'm going to open the file rcode session1. That is one of the shared files that I've sent you, and basically you have all the commands that we're going to use. Okay, so if you want to use, and I'm seeing already a typo, this should be capital F and capital O. Well, it's not important, but that's what I have in the slides anyways. But you can follow from here, or you can type if you prefer. Okay, so I'm going to create my first object called my first object, not very exciting name, that is going just to be the value 4. Okay, my first object 4. Okay, so R created as this now inside this object that is called my first object, and it has value 4. Okay, so if you ask R to show you this object, it will reply to you, well, this object is number 4. Okay, and now you can do things with this object. So if I say my first object times 2, R understands that I'm just multiplying the value of the first object by 2. Okay, we haven't changed by multiplying by 2. We haven't changed the object. Is still the object is still number 4. Okay, so not very exciting. It's just a very simple atomic object. And I should mention that with the syntax to name an object, I'm using this minus, less than and minus sign, to form this sort of arrow. So it's, if I rewrite this, it's first a less than and then a minus 4. Okay, you can also write is exactly the same thing, or almost the same thing, equal to 4. Okay, some people prefer to do equal, some people prefer to do the arrow. I think I'm more the type of arrow. There's a small differences in terms of programming about these two things, but it's not really relevant. In most of situations, they act exactly the same way. Okay, so this is how you name an object. Let's create a second object. And you can call it, you can name it as according to your preference. I'm going to call it my second object. And notice that R is case sensitive. So if I'm using, some capitals in the middle of the name, I'll have to repeat it like this. Okay. So my second object now is going to be not a value, but a vector. Okay. And the way I write a vector is with this C, comes from concatenate, C, and it's going to be the vector 1, 2, 3, 4. Okay? So I've created the second object. So if I ask R what is my second object, it's going to say, well, it's just the vector 1, 2, 3, 4. Okay? We follow here with the slides. Okay, so now we have an object that is a little bit more complex. Can you see well the R code? Some people were complaining about the size of the slide, so I'm concerned about the text in the R window being too small. Let's try to increase this a little bit like this, maybe. Okay, so I was saying we have a second object, a little bit more complicated. It's a vector. And I want to introduce now the idea of functions, okay? And functions are things that you apply to objects. And they always follow the same syntax. You do the function that you want to apply, parentheses, and the object in the middle, okay? So let's say that you want the mean of my second object. Katrina, someone raise their hand. Feel free to interrupt it if necessary. Let's say that we want...
Notice that. Vincent, I'm letting you talk.
Okay. Go ahead, Vincent. You're on mute. Well, while we wait for Vincent, so I was saying, now we're going to let's say we want to compute the mean of these 4 values, okay? The mean of the vector 1, 2, 3, 4. So there's a function that it's called mean, okay? And I, in parentheses, I put my object now, which is my second object. Mean of my second object, and R applies the function mean to my second object, okay? There's another function that it's, for example, standard deviation. So if I do standard deviation my second object, I get the standard deviation of this vector, okay? Okay. So we've named objects, but typically, unless you're programming or doing some some simulation with data, the typical situation is that you're going to have. So someone is asking, can you have 1 to 100 with a shortcut? Yes, So the question is, can you create my third object? I'm just going to call it my third. That is a vector from 1 to 100. And yes, there's all sorts of shortcuts. For example, in this case, it would be 1 semicolon 100. And so my third would be 1, 2, 3 up to 100. Yeah, there's all sorts of shortcuts. People that use R, a lot of programmers tend to be very lazy or very efficient, depends how you want to see it. So everything that would have an obvious shortcut, most likely will have. Okay.
Amanda, there's also a question on the Q&A. What's the difference between R and MATLAB?
Well, these are different programs. So MATLAB is also a programming language. It uses a slightly different syntax, grammar of language, but it's an alternative. Another common alternative for data science is Python. So I would say for people that really want to program, R, Python, and MATLAB would be the obvious choice. Again, this take it with a grain of salt what I'm going to say, but typically applied statisticians, coming especially from the biostats area, tend to use R. Computer scientists that come to data science, with machine learning and so on, they tend to use Python, and mathematical statisticians, they tend to use MATLAB. Again, there's a lot of overlap on these things, but that's my impression. The preferences are usually like this, and there's reasons for that, but it's really hard to argue which one is better. Okay, so let's move to something more interesting. As I was saying, usually not creating objects by hand. You're reading an object, something like a data set, and then you're analyzing that data set. And I think one of the difficulties in this introduction to R courses is that we spend a lot of time with programming aspects rather than going right into the data analysis part, right? So suppose that we have a data set that was created it can be Excel or a CSV file, or it can even be from other programs like SPSS or SAS or Stata, or so just a text file. But I have this data set that is here represented in Excel, although it's a CSV file. And this is a data set of transplanted patients. So it's based on real data, but with some noise to make it anonymous. So I have these variables: ID, sex, EGFR, cigarette smoking, lung disease, coronary disease, CVD, and so on. So I have all these variables, and I have the values for those 4 different individuals. So I want to read this in R and start, playing around with data. Okay, so depending on the where you have your data. In this case, as I said, I have it in a file that is a CSV file. You'll have to use a read something. Like, for example, if you have the file in SPSS, you can use a function that is called read.cspss, and you can import data from SPSS. In this case, I'm going to use this read CSV, and I'm going to copy paste this to the chat, because I don't want you to write those things. It's complicated to copy, but basically I'm reading the file from a share link in the Dropbox. Okay, typically you'd be reading your file, like look at here. You'd be reading your file from your hard drive, from your computer, right? And so you could use also the read CSV function, and you'd have to have the path to the file. In this case, I'm actually using a HTTP address to read the file, so you don't have to really to copy to your computer. Okay, so I'm going to also copy paste this here, so to the console. Okay, so it's reading the CSV. Enter. Okay, and it created an object called my data. Okay, and what type of object is this one? Well, it's a data set, right? So actually I can ask what object is this one. I'm going to use the function class, okay, that tells me the type of object. So if I do class parentheses, again, class is a function applied to object my data, and R is going to say, well, that's a data frame. Okay, well, good, excellent. Okay, let's try a different function to this object. Something that is quite useful is to do just summary, which again is a function of my data. And R is going to produce you a bunch of statistics for each one of the variables in the data set. Okay, so you have the variable ID, variable sex, and it's going to give you, quartiles, median, means. It's just a simple summary of the different variables in your data set. Okay, this is just to have a quick glance about on the data. I wouldn't recommend this for the analysis, just to have a quick glance on the data. I'm not going to get into details, but you can also see on your right side in the environment window, there's things appearing, and basically you have the details about the objects that you're creating. For example, here the my data, you can open it and it will tell you that there's all these variables and so on. So this is just RStudio helping you keeping track of the objects in that small window. Okay, I don't use it that much, but I see that it can be quite useful if you don't remember names of things and so on. Okay.
Amanda, there's questions about any websites you recommend for troubleshooting errors, and is there somewhere that has a cheat sheet or dictionary of different commands?
I'll come back to that at the end, okay, if you don't mind. Yeah, I have a few suggestions, but I'll come back to those questions in the end. I have a list of websites with more information and so on. Okay, good point. Just a small detail, and you don't have to necessarily run this, but just to show you that we've use this summary function applied to the object my data. And just to tell you that the same function, depending on the type of object, will produce different things. Okay, so the function is smart enough, or some functions are smart enough to identify the object and use it in the context of the object. So when I did summary my data, R realized that this was a data frame, so it produces statistics of the data. Okay, now I'm going to do something completely different. I'm going to produce a model. Okay, just a linear regression of two variables. Doesn't matter really, and I'm going to call it my model. Some lack of imagination here in the name of the objects, or some egocentristic behavior. Well, my model. Okay, so this is a model, linear model. If I ask R to show me the model, it produces, the intercept and age. So again, it's just a linear regression. But if I do summary, so the same function to this new object, which is, is not a data frame, it's actually the result of a model. R is, or the function is smart enough to say, okay, so this is a linear regression. So I'm going to actually present you some more details about linear regression. Okay, so just a note that the same function applied to different objects can produce different things. Okay, and sometimes, if the function is not appropriate for the object, it will give you an error. Okay, so more interesting things. So within this data frame, so someone is asking if you can save the file to your desktop. Yes, you can either do that or just go to the initial link that Katrina provided, that has all the slides and the transplant data set and all the other things. Okay, and you can read it, and you can save it in your desktop. You can read it from the desktop. Okay, I'm just using this HTTP because it was the easier way of everyone reading the same thing. Okay, so coming back to my data, this data frame, inside of my data, we have these variables, which are themselves objects, okay? And I can identify those objects using the dollar sign. So if I do, for example, my data, dollar sign sex, and you see, one of the nice things about using RStudio is that it, for example, it proposes immediately the names of the objects inside of my data. But if I do my data dollar sign sex, this will give me the vector of sex, so the variable sex in the data set. So I have the sex for all the individuals in the data set. So male, female, female, male, male, and so on. Okay. And so this would be the number 1, number 2, 3, 4, 5, so on. This would be 15 and up to 600 and something towards the end. So this is the object. It's a vector within the data frame, and it's identified by the dollar sign. Okay. So let's put some of these things together, okay? And suppose that we want to compute the mean of age, okay? So in this data set, and I'm going just to show you a little bit of the data set, I'm going to use this function head, my data, that's going to give you just a little bit of the data set, and you see there's an ID, sex, serum creatinine, I believe, EGFR, cigarettes, lung, coronary, so on, and age. So there's a variable age. Let's imagine that I want the mean of age. Okay, so I should be able to do this by now. So I want the mean in the console. I want the mean of what object? Well, my data, dollar sign age, right? And this should give me the mean of age, okay? Or the standard deviation of age would be the standard deviation of my data dollar sign age, okay? So because I know the name, the names of the objects within the data frame, I can now apply functions to those objects. Okay. For example, another thing that would be interesting to produce, for example, is just the frequency tables of sex. Okay. So how do I do that? Well, there's a function that it's called a table. Table for the object my data sex. Okay. Table applied to the sex is going to tell me that there's 255 females and 399 males in the data set. Okay. So try to get the number of patients that died. I'll give you 20 seconds. It's pretty much repeating the same thing that we've done. So table, and now the object of the variable, it's my data, dollar, and the variable died. Okay, obviously you have to know your data set, you have to know your variables and what do they mean. And this is not really coded, 0 and 1. I can tell you that 1 is dead and 0 is alive. So there's about 138 patients that died. Okay. Before we go on, let me teach you something else. Within each variable, we have the data values, right? And they also can be identified. Okay. So I've showed you before that when I do the object, the variable sex in my, $, in my data set, I get the sex of all the individuals. How do I identify this one, the value of this one? Well, I'm going to use now not the parentheses, which are for functions, but I'm going to do the square brackets, okay, which means position. So position 2. So I want the position 2 of the variable sex, and that should give me, if I go to position 2, it should give me female. Okay, so if I do this, it should, if I'm not wrong, it should produce female. Okay, position 1 would be a male, right? That's what 1 was before. Okay, and by extension of these, I could ask, well, what is the sex of the first 2 individuals in the data set? Okay, so I cannot just write 1 and 2 because this actually means something else. I'll have the vector 1 and 2. So basically I'm asking R to give me the values of the variable sex for individuals 1 and 2. Well, for the entry 1 and 2. If I resort the data, 1 and 2 will be different people, right? So if I do this, I'll have the male and female. If I want the first 100, as someone asked, I can do this, and I'll get the sex of the first 100 individuals. Okay? So you see, we can identify within each vector, I can identify individuals or records within that record. Okay? So if I wanted, let's say, the mean age of the first 10 individuals, not something very useful, but let's go along with the exercise. So someone is asking if you have a previous version of R. This is actually interesting. When you look at the variable sex, for example, it will not show you the between commas F and M. We're just going to have an F and M, and at the end is going to show you levels F and M. Okay, and this is just because the default on reading the file changes from one version to the previous version of the R to this one. So in the current one, this was read as a string variable, okay? Like M, the letter M, and F, the letter F. The previous version would code immediately these, and so it would be what is called in R a factor, if you want a categorical variable, that was coded M and F. That's why it shows you the levels M and F, okay? Again, I'm not going to get into the factors and when should you have, it should work very similar one or the other, having it like this or having it like factors, okay? So thank you for the question, because yes, it was actually me and Katrina, we are working with different versions, and I was getting confused why this was being imported as strings and in her computer was being imported as a factor with levels, okay? So I was saying, let's get the mean of the age for the first individuals. So how do I do that? Well, I want the mean. We should by now know the function mean. And now I have to identify the individual. So this is going to be my data, right? For the variable age. And now for what? Well, 1 through 10. Okay, so this selects the age of the first 10 individuals, and then the mean calculates the mean of those 10 individuals. Okay. Well, you could say, well, why would I want to compute the mean for the first 10 individuals? So let's do something more interesting. Okay, and I'm just complicating, you know, in a step fashion the type of examples. So let's suppose that we want to compute the mean age for only men. Okay. Okay. So how can I do that? Well, let's start with mean of what? Well, I want the mean for, it's going to be age, right? And now here I have to identify the men. Okay. And the way I'm going to do that, because it's not based on position, or it is, but it is, what is the position of the individuals? Well, it's where the variable sex is male, right? So that's what I'm going to write. I want the position where my data sex is, and I do equal with 2 equals, okay? That's the syntax to ask a logical question. Is this equal to, and now n. Okay, so by doing this, I'm selecting the ages of individuals where the sex is male, and then I'm computing the mean. Okay, and this would be the mean for males. If I wanted for females, you guess it now, it would be just those who are females. Okay, so it starts getting a bit complicated, and again, there's shortcuts for these things, but that's the philosophy. Okay. I'll leave this as an exercise to get the number of men and women that are older than 50 years old. Okay, you can try it. You have the solution there, but you can try it. Again, we're just going to apply a different function because now we're with the count. So it's going to be the function that we've seen before, table. And now I have to identify the individuals that are older than 50 years old. Okay, so you can look at it. And at this point, I should also say, because this, as I mentioned, this becomes a bit clunky. Something that it's becoming very popular is this alternative syntax, grammar, way of writing these things, which is implemented in a package called dplyr, and it allows a simplification of all this syntax. Okay. So a lot of people are using this new way of writing this type of commands. If you're starting, you might want to have a look at it, and if you prefer doing it like that with the dplyr, it might be a good way of doing it. I'm very used to the old way of doing things in R, so I'm still sort of stuck, although I'm starting to adopt some of these dplyr things. Okay, so just a comment. Okay. And I think this is the last part that I want to tell you in terms of position. The last thing I want to tell you about the positions in a data frame, right? your positions can be a little bit more complicated because it's not only the line, but it's line and column. Okay, so we're going to still use the bracket, but now we have to give the coordinates, and the coordinates are going to be, the row number and the column number. So let's say that we want to identify the serum creatinine of the first individual. So that would be my data at row 1, column 3. 3 because ID is column 1, sex column 2, serum creatinine is column 3. Okay. You could also, instead of calling it column 3, you can also call it by the variable name that R will understand. So if you do my data, row 1, column with the name SC1M, will give you the same thing. Okay, so basically, if you're working with the data frame and you want to identify a specific value or a set of values, you can also use this two-dimensional identification. Okay. So, for example, if you want, let's say, select only women from the data set, so use a subset of the data that's only women. Okay. So what I need to do is to identify, trying to explain this. I'm going to select, so I'm going to use the square brackets. I'm going to select the rows where sex is female. That's basically what I need to do, okay? So I'm going to say where sex is female. We should know how to do this, right? And comma, and all the columns. This will select all the columns, but only rows where the sex is female, okay? And this will give me just the data frame with women. It's all this. And I could, do the same thing and store it in or give it a name to this new object. I could call it my data, again, my data, F, females. And this would be a different object called, it would be another data set, but it's just with women. Okay. So again, I'm making use here of the bidimensional indication of the position of the values. What else? Let's create a new variable now, okay? Because also another common situation in your data is that, you want to create a new variable. And let's say that, serum creatinine is measured in millimoles, and I want to change it to milligrams per deciliter, okay? And the conversion is that I basically have to multiply the original values by 0.00113, okay? So we can easily do that by saying, well, my data string SC1M, which is the variable, right? This is the serum creatinine variable. And if I multiply by 0.113, I'll get a vector that it's now in milligrams, okay? But I'm not telling R to store it. I'm just, telling it to multiply. So it just produces the vector, but I didn't store the vector. So I basically have to give it a name. And I want to give it a name within the data frame, right? Because if I just give it a name, let's say SC dot milligrams per deciliter, if I just call it like this, it's going to be a separate object that is not connected with my data, okay? If I want to put it inside of my data, I'm just going to call the object my data $, and the new name, okay? And if I do this now in my new data set, not my new data set, in my data set, sorry, there should be a new variable at the end. Here it is. That is the previous variable multiplied by 0.0113. Okay, so we can add variables to our data set or make calculations. So someone is asking, can you run things from the script window? And yes, of course you can do this. So the way to do this would be, you can select, I know it's shortcut, let me see here so you can select the bit that you want to do and run that command. Okay, so I've just redone what I've done before, right? But running it from here. And so if I run these two things, I'll get the creation of the new variable plus just showing the data. Okay. There's other things that you can do, like, for example, categorizing variables is also a very common situation. Let's say that we want to categorize the age into 0 to 20 to 40, 40 to 60, 60 to 80. Okay, so the way to do that, there's actually multiple ways, but as expected, there's a function that does this type of things. In this case would be, I'm going to create a new variable within the data set, but I'm going to call it age cat. Okay, age categorical, and I'm going to use this cut function, which does, it cuts the continuous variable into bits. So I'm going to say, well, the variable age, I want to create these cuts 0, 20, 40, 60, and 80. Okay, and when I do this, well, now if you look at a little bit of the data set, again, this head function is just to show you a bit of the data set instead of printing everything. There should be a new variable age cat with the categories of age that I just created. Okay, so this first individual was 67, so it's within the category 60 to 80. The second one is 59 something, it's in the category 40 to 60. Okay, and it's open interval on the lower side and closed on the upper side. You can change this, but that's the default. Okay, can you get the categories now for this? Sorry, can you get the frequency for the age categories? Well, by now it should be simple. I'm not saying that you'll be able to do it just if you started with this a few minutes ago, but it's just applying the frequency tables command table to my data, the variable age cat that we just created, right? And we have the frequencies. Okay. Now, and I'm a bit late, but probably need 10 more minutes. So what about, I've just created this table of frequencies, and I'm just going to show you, I think the next command is really to introduce you the idea of libraries. So I've just produced a table of frequencies here, okay, just with absolutely frequencies. Can I get the percentage of these? And of course, there's a way of doing that. And the way of doing that, it's quite clunky in R. You have to use a function that is going to compute the proportions applied to this new object, which is a table, okay? So the function to get the percentages is called the prop table. Okay, so if people are leaving, I'm recording this, and if you want to listen to the final part, feel free to leave, and I'll probably upload it into YouTube and then share it somehow. Okay. So I was saying, if we want to compute the percentages, I would have to use this new, not new, this function prop table applied to the object table of the variable cat. Okay, so it's and you'll get the percentage of each one. So you see, it becomes a bit heavy in terms of programming. So this is, I would say, this is where libraries kick in, because if this is something that you want to do, many times, you don't want to write this code all the time. So you can create your function, right, that does all these together, table, and then applies the proportion of tables, okay? And you can create this function and say, well, this is really a useful function. I'm going to make it available to the community. And there's, certain rules that you have to follow. You have to create a small manual, and then you upload to this network of servers, to CRAN, and it become a new function available to the entire community. Okay, and this is basically what libraries are, or packages. Libraries or packages, it means the same thing. It's a function or a set of functions that someone spends some time developing and then sharing with the rest of the community. Okay, and I'm just going to show you an example of one. There's, as I said, more than 15,000. And there's a bit of digging if you need something. You have to search to see if there's someone created something like that. So one thing that we usually do when we do data analysis and producing a paper, let's say, based on the analysis, is to create this table 1 with baseline characteristics. And it's very it's very standard. What we do is like all the variables and then the frequencies and percentages. Okay, and maybe we also want to stratify by something, so we'll have 2 groups and all the baseline descriptions, and maybe sometimes we want to compare those 2 groups, and we could also add p-values at the end. Okay, so actually someone created a library, a package called table 1 that does all this. Okay, so how can I access this? I read somewhere that there's these very nice packages that does these tables. How can I access this? So I have to install this program. And how do we do this then? Okay, so if you're in R, we're going to Tools, Install Package. Okay. I'm not sure if you have this installed from already configured, or you have to actually select the repository. Mine is by default Australia, so I'm not sure if you have to do something there. It's been a while that I've installed R for the first time. And now I'm going to install this table 1, and I have to know, have an idea about the package. Otherwise, in 15,000, I don't have. There's no way that I can be exploring one by one to see if I found the one that I need. So table 1, and I'll do install. Okay, and R is installing, is downloading, and it downloaded. At this moment, it is in my computer, but it's not really active. And the libraries have to be activated every time I start R. Okay, so I've installed table 1, and now I'm going to load it, or load it is a good. It's like learning Kung Fu in Matrix, right? Now I'm going to load the program table 1 into my program. So I'm going to run this library table 1, write library table 1, and it's loaded. Okay, and within this package, there's a function that it's called create table 1. Okay, it's called create table 1. That's the name of the function. Okay, and I'm just going to say create table 1 data equals to, and I'll explain this in a second, equals to my data. So I'm applying the function create table to my data. Okay, and I explain why I have to write data equals to my data in a second. So if I do this, you see there's R created for each variable. It identified the type of variables. Of course, it did silly things like, it saw ID, and it saw it was a numerical variable and created the mean of ID and the standard deviation. Not very useful, but I didn't specify what variable, so it created for all the variables. For the categorical variables, it created the frequency and percentages. For the numerical ones, it create means and standard deviations. Okay, and you can change these. You can be medians and interquartiles and so on. But basically, someone, which I don't know the name of the person, but actually I love this library, spend some time programming all these functions that you can use, and basically produce table one's type of tables. Okay. And I said I would explain you why I have to put data equals to my data. Well, this table, this function create table one. I'm going to ask for help, and I'll do this by question mark function. Okay. I'm going to question mark create table one. It's going to go to help here on the right side. And you can see there's quite a bit of documentation. It's quite useful, this documentation. One thing that I like a lot is at the end, there's always an example, okay, that you can run and see how it's applied, the function. But if you look at the the details of the function, you see that the function asks you a lot of questions, and a lot of these questions have a default value. Okay, so for example, include NA is false, so it's not going to include missing data. If there's two groups, it will test for you, and so on. But because there's so many things, it's better to tell R what are you providing, and in this case, you're providing the data. So you're providing this element, which is the data. So I'm saying create table one data. It's my data set, and everything else is just default. Okay. And again, if you want to tweak now this table, and change things like number of decimal places, median instead of the mean, and so on, you can do that, but you have to change some options of the function. Okay. So libraries work pretty much like this. Someone creates a function or a set of functions, creates the manual, which usually includes an example that I think is the most useful part of the manual, and it makes it available to you. And there's pretty much functions to do anything. Okay, very specific things on machine learning and so on. Other more complicated or more specialized, like bioconductor, is a big library of functions to work with, for example, genomics. Okay, so I have some more examples of these create table one now stratified. I'm going to jump that. So it's hard to keep track of all the libraries, obviously. This is a list of the 20 best libraries for data science that was already a bit old. So this is from 2018, December 2017, from Active Wizards, which is the company that works with R as well. A lot of these things are really for machine learning type of machine learning algorithms, but this according to their criteria is a collection of 20 good libraries. I'll leave it there in the slides. And in the RStudio support page, there's also an updated blog about useful R packages. Okay, so I'll leave you the link there, and it's useful just to keep basic functions about data management, about summary data, about simple graphs and so on. Okay, so this is a good reference to have. So I'm going. What time is it? 5:40. So the introduction to R would be finished by here. I'll just spend 5 more minutes, and again, if you need to leave, that's fine. I just wanted to give you a flavor of what is to do an analysis with R, okay? Like a real analysis with R. And I'm not going to get into details of the statistics, but in this case, like we have the transplant data, we have an event that is death, and we have follow-up time, okay? So one thing that we could immediately think about is some survival analysis on this data set. And let's suppose that I wanted to compare the survival time of males and females. Okay, so I'll have to use specific libraries for survival. So there's this library survival, which is the basic library with basic survival functions. And I'm going to also use this serve miner, which has some nice plots, some functions to produce some nice plots. Okay. So the first thing I want to do is to create a Kaplan-Meier. And again, I'm going to go very fast from here because this starts to be stats and not really programming, but just to give you an idea about how does an analysis look in R. Okay, and I understand this is complicated, and I picked up sort of a survival analysis, which is not the easiest example, but just again, as I told you, just to give you an idea about how these things are implemented in R. So I'm going to produce the Kaplan-Meier for survival time according to each sex, and this is the object surfit. Okay, so I'm going to run this little bit, and now I'm going to plot the Kaplan-Meier object. Okay, so I'm going to plot the Kaplan-Meier object. I'm going to increase now R bit. So I'm going to use this GG survival plot, and it's going to show me the survival curves for males and females, and perform a log rank test, because that's actually what I've asked. P-value true, it tells the function to plot the log hazard, the log rank test, comparing these two Kaplan-Meier curves. Okay, so I'm looking at these. The survival curves seem to be very similar, but let's say that I want to dig a little bit more and see what if I adjust for other covariates. So in this case, I'll probably want to run a Cox proportional hazard model. That's what I'm running here. I'm going to give a name to that model. As I said, everything is an object for R, so my model is going to be an object as well. So Cox proportional hazard for the time to death using sex, age, and EGFR. Okay, and the data set is my data. So I'm going to run this. I run the model, it's stored. So if I do summary of the model now, I can see the results of the model. So basically it tells me, give me the results for a Cox proportional hazard. So it gives me here the hazard ratios, the confidence intervals, and also the p-values. Okay, it tells me that sex is still not significant, age is significant. Okay, and then you'd would want to go on exploring, for example, like assumptions of the Cox proportional hazard. Okay, and so I could, for example, look at the proportionality assumption. Okay, and see, for example, in the graph of the residuals, if I see departures of the proportionality assumption, and it also produces me automatically the tests for proportionality. Okay, so this little bit of code, which again, this is the most sophisticated part, is just to show you how an analysis would be performed in R. Very simple, like complex analysis, but very few steps. Probably I would want to dig a little bit more into the data. Okay, so this is typically what you'd be storing and doing. So I'm leaving several links with different resources. So there's this course at I shouldn't be promoting the Harvard School of Public Health, but they have this very nice online course for free, statistics in R, and it's from the biostats perspective. So the people who teach the course are a biostatistician. There's specific courses for, let's say, survival analysis, logistic regression. In this datacamp.com, there's other things that you can explore. This is also a good resource. There's a free ebook on introduction to R, and these 3 links, it's are blogs that I follow that gives me some news about R. So just to complete the question that someone asked, so these are what I would recommend in terms of resources for R. In terms of interpreting errors, for example, I don't use one single resource. What I usually do is I copy the error into Google, and hopefully someone has written something about that error. So I don't use one specific. There's quite a lot of mailing lists and open groups that discuss statistical problems, but I think it's easier really to search the error in Google. And And as I said, most of the times I find an answer for the error. And even when I look for something, how to do this in R, it's usually pretty straightforward to get a link with an answer to it. It's quite incredible the support that or the time that people spend making things available to other people. Okay, so this is what I wanted to show you in this first session. Again, it was the basics of the programming with R. As I said, we're going to have a second session next Monday, and we'll focus on something that is really cool: is how to produce graphs. Because aside of the programming language that we've seen today, there's a specific grammar, there's specific syntax for plots implemented with this ggplot, and it's, I wouldn't say that it's simple, but makes possible, or it's pretty much possible to do whatever you want in terms of graphs. Okay. So someone is asking, cannot find ggservplot. Maybe you have to install the servminer package. Have you loaded the library servminer package? So just to answer that question, you need this package to do that. How to register for next session? You just show up. Okay, we have 500 spots for these seminars. I don't know how many we had today. I saw 140 people at a certain point. I don't know if we had more than that, but that should be.
The link will be the same.
The link will be the same, and the links will be the same. Also, the Dropbox and so on will be the same. We're also going to use the same data set. So only the person leading the presentation is going to be different. It's going to be to Katrina instead of me. Okay. Feel free to ask any questions if you want to stay a little bit more. Cox models your life lately. Lucky you, huh? Share the questions and answer, please. Okay, I'll try to save that as well and share it with you guys. How do I know if a package is already installed? Well, that's a good point. You can try to load the package, and if it's not installed, it'll give you an error. Okay. Or you can install it on top of, it doesn't matter if you install it on top of the previous one. It's fine. Yeah, I'm not sure where we will save the video. I'll most likely in YouTube. The problem is how to share the link. Probably in the newsletter of the faculty. I'll try to share it, and if I somehow get the emails of the people that registered at the beginning, I think it asked you to register, to give you the email up. I can also send the email with the link. Can you please have the PPTs? Sure, it's already in Dropbox, in the shared Dropbox. Katrina, do you mind just putting it?
Yeah, sure.
Just Katrina will write the link for the Dropbox for you to download the slides. The table one did not load. Well, if you do install packages, tools, install packages, and if you start typing table one, you have to find it there. If it doesn't appear, you have a problem, but if it should appear, and if you click it and do install, it should install. And then do library table one, okay? Not with capital T as you had in your question. So it's Could you save the video to the Dropbox and share the link that way? Yes, I can do that as well. Yep, that's fine. It's going to be a very large file, but yeah, I can do that. I try to follow the Kaplan-Meier survival analysis, but getting an error message. Were you able? The first thing that you want to make sure is that you've loaded the two libraries, the survival and serve minor, and then go from there. And then try to execute one line at a time to see if you find the error. Where is the error? So if I upgrade to the latest version, will that mess up my current script? No. So actually, it's if you even with RStudio, if you just upload the new RStudio will immediately identify the new version, and the only thing that you lose is the libraries. So you have to reinstall the libraries that that you're using, or because the libraries become are not compatible, or sometimes they have to be updated. So R doesn't reinstall automatically the libraries. So the only thing is when you update R, you have to also to download the libraries. But again, you can do that when you need them. How do you cite a library package in your manuscript? I'll leave you for you to look for this. Just search Google how to cite a library package in R. Okay, you'll find the answer. And actually there's a function to tell you how to cite a package. It's just cite and the name of the package, but you can just have a go with it to search in Google for how to cite the library package in R, or R library package. So when installing table 1, there's an error. There's binary versions available, but the source versions are later. Is this because I have the most recent? There are binary. So when you try to install Lucy, I think it asks you a question at the end of that message. Just say no. Again, I'm not sure what the error is. So you're saying that there are binary versions available, but the source versions are later. So just say no to the question if that's the case. There is an error when I type library serve minor. So make sure that you have the package installed, right? Okay, so you can actually, if you look at my R now, I think I'm still sharing. Am I still sharing? I am, right? So you can actually do manually install serve minor. And if you execute install package, it will install. See if you can do it this way. Install package serve minor. Okay, the error was because I've canceled. You can generate a list of participants and their emails via the meeting details. Okay, thank you. Thank you, Bonnie. It's the first time that I'm using the webinar option of Zoom. Yes. Okay, thank you. Information about Zoom. Hi, Erin. Thank you. Nice to see you here. When will the link become available to register for session 2? It's already available. It's the same link, okay? And you don't need to register. Just when you enter in the session, it will ask you for your email. I remember someone showing me that I could see the results in the code. No, Vincent, you're right, but that's in R Markdown. So when you're producing this, text, and in the middle you're putting R code, there's an option that actually it will execute immediately after that. I think that's what you're referring to. That's when you do an R Markdown type of object, R Markdown, not object, sorry, document. So something like this, you see, you'll have text, and then you have you'll have code in the middle of the text, and it executes in the middle of the text. I actually don't like this very much because it becomes very confusing, but it executes rather than in the console. Or outside, I should say, it also executes in the console, but it shows also the result here in the middle of the text. Yeah, so you see, for those that are still on, you see this R Markdown file. Okay, so this is just a simple example. So it has text, there's some code summary, the data set cars, plot pressure, some other stuff. So if I execute these, I'll have to save it somewhere. Just going to say text test. Of course, it does exist already. So replace. It's going to produce, in this case, an HTML file that execute. It has a text plus the execution of the code. Okay, so it can actually also produce a PDF. I'm going to produce a PDF. Here we go. So it produces, this is an R Markdown. So this is an R Markdown document, and then it executes the commands and puts them in the middle of the PDF. Yeah, good. Okay, so I think we're done. Thank you, Katrina, for helping. I lost track of the chat. I hope we were able to answer to most of the questions. There was a lot of things. I think we can save this. And hopefully we'll see you next Monday. Any other questions? No worries, Marisa. Nice to see you as well. Ciao, Patrizia. So I don't think there's more questions, so I'll probably stop recording.